The Milky Way contains over 100 billion planets and moons, but only a handful can sustain biological life. But what if humans could modify the ecosystem of any cosmic body in our galaxy? What if we could change the temperature, thicken the atmosphere, and create another green planet? In the 1940s, author Jack Williamson coined the term terraforming. To terraform is to create an ecosystem that supports living organisms, from large, complicated vertebrates to simple, unicellular bacteria. Unfortunately, no cosmic body has ever been terraformed. It's an incredible feat that we as a species are far from achieving. But let's jump a few hundred years into the future. If we could terraform another planet, where would we start? Our most promising candidate isn't actually a planet, it's a moon. The very same moon you see glowing in the night sky. What makes the moon an ideal candidate for humanity's first adventure in terraforming? The moon has one major advantage over every planet in our galaxy. It's only a short space flight away from Earth. Of the 7 non-Earth planets in our solar system, Venus is the closest. The distance between Earth and Venus ranges from 162 million miles to 24 million miles, but the latter only happens once every 584 days. Traveling such a vast distance creates an incredible hurdle for our limited technology. On average, the Moon is about 240,000 miles away, a fraction of the distance between Earth and Venus. A shorter spaceflight opens up all kinds of possibilities: shipping supplies, transporting parts, carrying astronauts and colonists. A smaller distance makes everything easier and significantly less expensive. Though the distance between Earth and the Moon is comparatively small, the Moon is far from perfect. Its dead and desolate ecosystem presents a number of environmental challenges. First and foremost, the Moon's atmosphere is unbearably thin. It's made of a paper-thin layer of gases, which form a lunar exosphere. This exosphere contains just 100 molecules per cubic centimeter. For reference, Earth's atmosphere at sea level contains 100 billion molecules per cubic centimeter. As it stands today, the Moon's exosphere cannot support biological life. So how do we thicken the exosphere and create a life-bearing ecosystem? The Moon's exosphere remains razor-thin because it lacks the gaseous density of Earth's atmosphere. If we're going to thicken the Moon's exosphere, we're going to need more gas. To spread gas around the exosphere, we'll need a series of icy comets that we will crash into the surface of the Moon. When these comets come thundering into the Moon's exosphere, the impact will populate the exosphere with a surplus of water vapor. Water vapor contains oxygen and hydrogen, which are 2 essentials for biological life. But we need at least one more element to create breathable air. The last piece of the puzzle is nitrogen. Aerospace engineer Dandridge M. Cole claimed a gas called ammonia could fill the atmosphere with nitrogen. Cole designed his proposal for the red planet Mars, but the same strategy could potentially thicken the Moon's exosphere. Humans could import a large quantity of ammonia, which would fill the Moon's empty exosphere with nitrogen. Ammonia would also trigger the greenhouse effect, trapping and reflecting heat from the sun. This brings us to another significant roadblock: the Moon's wildly changing temperatures. During the day, the Moon boils. At the lunar equator, temperatures climb to a fiery 250 degrees Fahrenheit. In the evening, they plummet to the opposite extreme. Freezing nights fall below -200 degrees Fahrenheit around the equator, while deep craters at its northern pole can reach -410 degrees Fahrenheit. That's about 266 degrees colder than the coldest temperature ever recorded on Earth. Why does the Moon's temperature fluctuate so dramatically? It doesn't have an atmosphere to protect and insulate the surface. If humans tried to live on the Moon right now, its radical temperatures would make our lives a living nightmare. But a surplus of gases like hydrogen, oxygen, and nitrogen would thicken the atmosphere insulate the surface, and create a protective bubble from the sun's violent rays. Say we crash 100 icy comets into the surface of the moon. Say we import an excess of ammonia into the atmosphere, and the moon's harsh ecosystem grows more livable. Soon, we would build the first lunar settlement. What would life be like for the first group of settlers on the moon? Colonists may notice a surprising number of similarities to life on Earth. For starters, the moon's rotation could hypothetically be sped up to match the Earth's 24-hour cycle. Currently, one lunar day spans almost 30 days on Earth. The moon is tidally locked to the Earth, so the moon rotates incredibly slowly. By purposely crashing 100 comets into the surface of the moon, we could speed up the moon's rotation. The impact could free the moon from the Earth's tidal pull, thus changing its day and night cycle. Lunar colonists may also notice a valuable resource on the surface of the moon. Because we populated the moon's atmosphere with water vapor, lunar colonists may discover reusable sources of water. Renewable water means renewable energy, which could power equipment, grow food, and foster new life on the moon's desolate surface. Of course, everything we've discussed so far is theoretical. Countless problems could arise at each and every stage. What if the ammonia doesn't trigger the greenhouse effect? What if the moon can't handle 100 comets crashing into the surface? What if the moon's atmosphere changes in ways we aren't expecting? And how would we deal with such low levels of surface gravity? It could mean devastation for our bodies. Terraforming is still a very distant concept for our species. A lot could go wrong, because there's a lot we don't know. Humans have only recently entered the space age, yet here we are, contemplating interplanetary colonization. Each day, our theories push us further, and our plans grow more detailed. But we have a long way to go before colonizing another planet. If and when we terraform another cosmic